Good afternoon. My name is Ravi Babu, first time professor in Institute of Aeronautical Engineering College. Now I am going to taking a class on digital control system. In that one, today my topic is applications of jury stability test and bilinear transformation with Routh stability test. Yesterday, in previous sections, we see the introduction, asymptotic stability, Vibo stability, internal stability, jury stability, and Routh hedge stability criteria. Now, I am going to move into applications. That is, I am taking the one problem in case of the applications. That is, here I am going to finding the K value. K value. That is, the range of the K for sampler and hold device if it is removed. So, in a problem, they given that the circuit is containing the zero order hold device, that is GH0 S, and a pulse function t equal to 1 second, and one system, that is K by S into S plus 2. These are blocks are in forward path, that is G of S and hold device, G order hold device, and sampler function are in forward function, and these terminals are connected to with unity feedback system. Unity feedback system with negative feedback. Okay. Generally, in case of the practical applications, the negative feedback is very useful for finding the system behavior. Why? Because it will having the less oscillations, and compared to exact output, values will be get exactly with less iterations method. So, first of all, in this problem, we have to analyze the transfer function. That is, it is not only finding the range of the K value. We have to first analyze the transfer function. After that one, we have to take the characteristic equation. After that one, we are going to here finding the stability from jury stable conditions and RH criteria conditions. So, it is applicable for the having the sample and hold device. If sampler and hold device is not present there, what happened we can see also. That's why now we are considering here the problem is having the total 3 components, that is sampler and hold device, and geo-holder device, and a system. So, I am taking the first of all, for a given system, the transfer function. For the given system, the transfer function. That is, output function is here, I am analyzing the output function as y of z, and the input function as r of z. So, taking the transfer function of this one is output by input, making the initial conditions are 0. That is, if you considering this one, there is y of z by r of z equal to, so the forward path is g into h0 of s and g of z. That is this function. This function in a problem I am taking as g of s. So that is here. In case of this one is I am analyzing with z plane. Okay, z plane. So g of Z by 1. Here I am considering as a negative feedback system. Negative feedback system. So it is coming to as 1. Here negative feedback system we are having a minus. So it is coming to as plus. It is coming to as plus. It is minus there. So it is coming to as plus 1 plus loop of this function. Loop of this function. That is, it is forward path G H naught, zero order word device, into the system G of Z into 1. Feedback will be 1. In our practical examinations, if there may be, the feedback will be 1, otherwise any gain values, anything, for getting the output values. If you take 1, nothing but every time in iteration, the output value is multiplied with 1 only. Then only you have to analyze how much of quantity is going to be variated in input and output section side. Input and output section side. That is, the main advantage of this one is unity feedback system. Because of the unity feedback system, we have to easy to analyze the output for getting the optimal solution. Output for getting the optimal solution. That's why always for calculation for that one, analyzing any system, generally we take the unity feedback system. Unity feedback system. Otherwise, if you are having the output with multiple solutions, if difficulty oscillations, then only you have to simplify the feedback system with linear solutions. Linear solutions. That's why it is I am taking here applicable for the unity feedback system. Unity feedback system. Now, coming for this one, the denominator part of this one is, the denominator part of this Cauchy equation is represented as the Cauchy equation. The Cauchy equation. That is, for analyzing the any system, closed loop control system, in your problem, it is a unity feedback control system. So, for analyzing the any unity feedback control system, first of all, we have to take the Cauchy equation. What do you mean by Cauchy equation? Cauchy equation is the thing, but denominator part is coming to equal to 0. Denominator part is coming to 0. In a system, our system is given as denominator part is 1 plus G H naught G of Z. G H naught G of Z. So, this value is going to be 0. This value is going to be 0. That is your Cauchy equation. That is your Cauchy equation. Coming for here, in the Cauchy equation, we having the whole device and G of Z, one system. This whole device and the system, one of the system, G of H. G of Z, sorry. G of Z. So, these, we have to find this value. We have to find the value. That is, G into H naught into G Z equal to, it is value. I want to find G into H naught into G of Z equal to, so Z transform of, what is the transfer function of the zero order word device? In previous sections, we have to already study. That is 1 minus e power of minus s tau by s. 1 minus e power of minus s tau by s into k by s into s plus 2. S into 2. This is the zero order word device. This first term is the zero order word device transfer function. Okay, and this is the, in problem they given one of the system function k by s into s plus 2. K by s into s plus 2. Okay, so this is your zero order whole device transfer function. Zero order whole device transfer function. So, coming for here, the Z transform of this one is, okay, 1 by e power of minus e power st by s into 1 by s into s plus 2. 1 by s into s plus 2. So, we have to take the Z transform of these two terminals. two components. Why? Two components. That is, k is the constant. K is the constant for first term. That is z minus 1 by z into 1 by 1 minus s square plus s plus 2. This is the z transform we have to find. Okay, we have to find. So 1 minus e power of s tau by s tau. What is the z transform of this one is? That is z minus 1 by z. Z minus 1 by z. That is nothing but 1 minus 1 by z. 1 minus 1 by z into 1 by s power e. Simple. This is nothing but z minus, sorry, so here z minus 1 by z nothing but, okay, 1 minus 1 by z. 1 minus 1 by z. Okay. A minute. That is 1 minus 1 by z. So what happened? For this one, 1 minus e power still nothing but 1 by z. E power still nothing but 1 by z. So the transform of this one is this one. K is the constant. Z transform of 1 my constant term 1. Okay, minus 1 by z. E power of minus s nothing but 1 by z. Okay, so into z transform of remaining term is 1 by s into s into s plus 2. That is s square plus 2. S square plus 2. Okay. Just mathematical transformation, mathematical calculation part. Okay. So it is constant term, same z minus 1 by z into. Coming for here, already we see the basic terms. That is, it is a 3 components function. So I am taking the partial fraction of that one. Taking the partial fraction of that one. That is a by s square plus b by s plus c by s plus 2. C by s plus 2. Why? Because here s value is having the square term. So higher order to lower order, you have to divide that one term value. That is the term value. So that is a by s square plus b by s. This is for only for this one. And plus c by this term. C by s plus 2. C by s plus 2. So it is the function we have to divide into 3 terminals values. 3 terminal values. So what is the a value here? A is nothing but 1 by s plus 2. 1 by s plus 2. Where s equal to 0. Where s equal to 0. Okay. So it is, I want to find the a value. I want to find the a value where this denominator term, which term is in denominator of the a term, is s square equal to 0. That is nothing but s equal to 0, no? S equal to 0 completed. So it is, I am using here this term. I am using this term 1 by s square term. So what is the remaining term? Remaining term is 1 by s plus 2. That's why I am writing here. This is a partial fraction method finding values. Okay, partial fraction method finding values. So it is coming to as 1 by s plus 2 where s equal to 0. If you stop to this one is, it is coming to as 0.6. 0.6 value. Okay, 0.6 value. I think 0.5, sorry. It is 0.5. It is 0.5 value. Okay, 1 by 2, no? 0.5 value. Next. After that one, for finding the partial fraction of first b term, okay, for finding the partial fraction of b term, that is, the b term is the inner function of the highest order term. The b term is the inner function of the highest order term. That's why we have to make the derivative of remaining term. Okay, the b term is, below term is s value. It is function of the s square term value. Okay, it is function of the s square term value. So we have to derive to the remaining term. It is a property. It is a technique for finding the partial fractions. Okay, so d by ds of s plus 2. Okay, d by ds of s plus 2. This is the way you have to find. Where s equal to same, this part equal to 0. Equal to 0. Okay, so if you take the first of all for this function, the derivative part, that is 1 by 1 plus, sorry, minus is coming. Okay, derivative of a by b. Okay, a by b. That is nothing but minus 1 by s plus 2 whole square. Sub to the value is s equal to 0. What happened? 1 by 4 is coming. What is 1 by 4 value? Its value is 0.25. 0.25. So minus 0.25, we got the value. Okay, coming for the C value. For C value is denominator term is s plus 2. So s plus 2 equal to 0. S equal to minus 2. So applicable value is s equal to minus 2 completed. Applicable value is s equal to minus 2 completed. After that one, the function, where in a given problem I am taking as c by s plus 2. So what is the remaining term? Remaining term is 1 by s square. So that value I have to write down here, 1 by s square. 1 by s square. So what do I have to get? For finding the s equal to minus 2, 1 by 16. How much value? 0.25. 0.25, we got the 0.25. Okay, this is the way we have to find the partial fractions. The partial fractions. It is 0.6, so 0.5. Okay, it is 0.5. Coming further. Okay, coming for that one, we have to substitute the values. K into z minus 1 by z into 0.5. A value is how much value? 0.5. B value is minus 0.25. C value is 0.25. Same. Okay. 0 value is 2. B value is minus and C value is plus. C value is plus. Substitute these values. After that one, simplify this one. Simplify. Okay. It is first term is multiply with second term. So what happened this one? This one is coming to as denominator part 1 term and numerator part 1 term is cancelled. So it is coming to as 0.5 by z minus 1. Z minus 1. Okay. So next minus z minus 1, z cancel. Only 0.25 is there. Only 0.25 is there. Okay. Why it is coming to t? Here t is not there. So take care. T is not there. Next one. Plus z minus 1, 0.25 into z minus 1 by this z and this z is cancelled. Okay. By z minus e power of minus 2t. E power of minus 2t. E power of minus 2t, nothing but t value is minus 1 seconds, no? T equal 1 second. Sorry, t equal 1 second. T equal 1 second, nothing but z minus e power of, for this value, z transform, okay, value is 0.25 into z by z minus e power of minus 2t. E power of minus 2t. Okay, e power of minus 2t. So, here t equal to how much value? 1 second. 1 second value. Okay. So 1 minus e power of z minus e power of minus 2t. It is a formula for this one. So simplify this upper function. That is 0.25 by z minus 1 plus 25. This is the simplification value. Simplification value. Now take the LCM. Take the LCM. Okay. By taking the LCM, this part is multiplied with this one. That is z square minus 0.1353 plus z plus minus 1z plus 0.1353. So for simplifying denominator value, this is coming to this value. Coming for the above value, numerator value, 0.5 into this term, LCM. Okay, this term plus 0.25 into these two terms. These two terms values. Same. Okay. Same. Plus 0.25 into this one is cancel. You have to take it as 0.25 minus 2z plus 1. Okay. By this value, total value, multiplication value. Okay. So simplifying this one, we get the, that is 0.2838z plus 0.1585 value, that is but deviation by this one. Coming for here, this is K, forward path gain. Forward path gain, that is forward path function, transfer function. Now, what is the P of Z? P of Z is nothing but 1 plus your order of device with forward path function. Forward path function, that is P of Z equal to 1 plus K into, what is that value we got? G of Z by value, this one value. Okay, this value. So, up to the definite there. After that one, you have to take this catch equation value equal to 0. This catch equation value equal to 0. So, what we have to get? Z square minus 13.23 Z plus 0.153 plus this value into K plus this value into K. This value into K. So, arrange the values. Arrange the values with order of Z values. With order of Z values. So, what happened? Z square plus Z into 0.2838 into K minus 1.13 plus 0.1353 plus 0.1485 K equal to 0. Equal to 0. Simplifying this one. Okay. Simplify this. Now, we got the transfer function of the transfer function of this one system. Sample and whole device system. With one system. Next. Coming for the jury stability test. Jury stability test. Okay. Coming for the jury stability test. Up to now, we find the, for given system, we find the transfer function, that is negative feedback transfer function, that is forward path with unity feedback system. Find the transfer function. After that one, in transfer function, we have to find the cache equation with sample and whole device. Sample and whole device. Okay. With sample and whole device. That is t equal to 1 second also. T equal to 1 second also. Okay. Sampler. This is your sample. Characteristic equation. That is your characteristic equation. Characteristic equation. Now, go for the jury stability test. Jury stability test for this application. We know the necessary conditions for jury stability test is, first of all, you have to find the P of 1. P of 1. Substitute P of 1 value in this characteristic equation. This characteristic equation. Substitute the value of this one here. Which value? P of 1. 1 value. So, what happened this one? 1 square nothing but 1 plus 0.25k minus this one value. Same as this. Same as this. We get out as value is this value. So, what is the condition there? Compulsory there will be a greater than 0. Compulsory there will be a greater than 0. That's why it is coming to greater than 0. Greater than 0. So, after that one, I am going to necessary conditions. Necessary conditions. That is, minus 1 whole power of n into P of minus 1. For that one, we have to substitute first minus value multiplication factor. After that, P of minus 1. P of minus 1. So, what is that one? Value tell me. Z square plus Z into this. Here, in this function, I want to represent minus 1 whole power of n into P of minus 1. This is necessary condition second one. Necessary condition second one. Okay. So, if you submit that one, minus 1 P of minus 1, we got the value as 1 minus value, this value, up to this one, we got the greater than 0. Greater than 0. Okay, this is the one of the necessary condition. Go for the last necessary condition. Last necessary condition. That is nothing but, what is the highest power of the Z? That is second order system. Okay, second order system. What is the lowest order of the Z? Z of 0, that is 0.1485. 0.1485. So the highest value of the Z0 is nothing but 0.1353 plus 0.1485. Last one. Okay, last but one. This one. 0. See, A2 0.1353 plus this value. Sorry, this value 0.1353 plus 0.1485. Okay, 1485. What is the A0 value? A0 value, A0 nothing but what? This one. 11. 1. This one. A0 value is this one. Compared to standard formation. In last classes already I have told you. Compared to standard formation. So, we are getting as, substituting these values, we are getting as, this is the value is always less than the 1 value. Always less than the 1 value. That's why A2 is less than A0. A2 is less than A0. Therefore, I am going to checking whether it is not interchangeable. That is 0.53 plus 0.1458 is less than 1. Less than 1. Okay. So, finally what I am saying is, the form condition is minus 1 where k equal to 0, greater than 0, minus 2 where k equal to less than 16.17840, minus 3, that is nothing but 3. Third form condition is k less than or equal to 5.89, 8229. 8229. So, the range of the stability will be in between these two. In between these two. The stability of the system is in between these two. This is your stability. In case of the jury stability condition. Jury stability condition. Now, in this case, we will find the k value range. K value range. So, I am going to with same problem with bilinear transformation. Bilinear transformation method. That is z square. What is the characteristic equation we got? This one, no? We got this characteristic equation. Okay. This one we got the characteristic equation. Take that characteristic equation. Take that characteristic equation. Okay. Take that characteristic equation and by using bilinear transformation of the RH criteria. RH criteria. Okay. That is nothing but, first of all, we have to take this value where z is there. We have to substitute 1 plus omega is there. Okay. Omega is there. 1 plus z by omega by 1 minus omega. 1 minus omega. Substitute this value into here. Okay. Substitute this value into here. So, 1 plus omega by 1 minus omega whole square plus 1 plus omega by 1 minus omega, this value and this value, plus, okay, constant term. Constant term. Okay, so simplifying this one, above equation, simplifying this equation, we got as omega square plus 2 omega plus 1 into 1 minus omega square 0.2838k minus 1.1353 plus omega into minus omega square into 2 omega plus 1 and the last term constant terms. Constant terms. This is the got we got it. So after that one we can find the table. Routh array table. Okay. Routh array table. So simplifying this one, we got the final value is this one. Okay. We got the final value as this one. That is, we got this final value. Okay. We got the final value. Find the Routh table array for this one. Routh table array. Okay. Routh table array. So what happened? First term is 1 minus omega square term. First one is, how many term variables, state variables is there? There is two variable state variables, that is 0, omega 1, omega naught. Okay, omega square, omega 1 and omega naught. So what happened? The first term says 2.2706 minus 0.1353. What is the second term is there? Any zero term? No. That's why it is empty. Coming for the second row, that is 1.7920 minus 7990. That value is the single value is coming. And last term, W0 value, constant. Okay. So how can you find this one? It is this. Okay. Now we form the Routh array table. Find for the checking conditions. So that is if k greater than 0, that is nothing but this value is getting to stable condition only. Okay. I reversed with one, take reverse one, that is 1.7229 minus 0.29 k greater than 0. From that one, we would say that the above value is between less than 5.8229. So we got that one is the third condition. First stable condition is this one, 2.2703 minus 1.345 greater than 0. Okay, greater than 0. Okay, this is also greater than 0, nothing but we got the less than of 60.781. Simply, what I am saying, it is from first one, it is from first stable condition. It is. Okay. What is the next one? This second part. Put 0. Okay. The third one, this is the third part. Okay. We got the third part. Finally, from these equations, what you get the range of the k value is between 0 to 5829 range value. So how can you get? Why you not to taking this 16.7820? Okay, it is bigger value. That's why. The previous one, what is the range of this one? 5829, no? 5829. Okay, 5829. We got the values here also. The range will be 5829. Similarly for here also. 5829. Okay. Sorry. K value is between 5 to 9. So we got the value. Okay. Next. Okay. We got the K value between 0.5829. Next. Coming for the Routh array. Okay. So what happened? There is no sign changes in first column. So it is a stable condition. Okay. It is a stable condition. Remember that one. Okay, k value substitute this one. We got this value. Final value is 0.5. We have to make it change on this one is stable condition only. So I am going to checking the same system without pulse and zero order load device. This is application. No. What I am saying is this is application. In first application, I am taking as with zero order volt device, and pulse function. But what happened in application point of view? I am taking the function as without pulse function and zero order volt device. So what we have to get? I am taking without pulse function and without zero order volt device. That is normal closed loop control system. I am taking normal closed loop control system with unity feedback. Now solve for this one. So what is the happen? The closed loop transfer function is k by s square plus 2s plus k. Okay, we got it. What is that one? Once I am repeating, k by s into s plus 2 by 1 plus k by s into s plus 2. So what is the value get? You got it. It is taking the LCM denominator side. So what are you getting? That is s square plus 2s plus k, and given part is k. Given part is k getting. Okay, so we're getting this one value. We're getting this one value. Therefore, what happened? The denominator part equal to characteristic equation. So I'm taking the denominator part is characteristic equation. After that one, I'm going to making the Routh table for this one. Okay, for this one, I'm going to making the Routh table. So what happened? If you find this one values, that is square term 1. Okay, next one s term is s square. Okay, next constant term s4 0 term zk. First row is completed. Coming for the second row, what is that one second row? It is 2. It is 2. So we got the 2 value also. After that one, for find the third row, that is AD minus BC. What is the value AD minus BC? 2k minus 1 by 1 into 0, 0 by 2. So we got the, it is k value. It is k value. Okay, we got this one. K value we find. Okay, so what happened one time? For stability condition, the k value is the stable condition. Okay, k value will be greater than 0 and less than the infinity. Between the, that is k value is between 0 and 1. Okay, here problem, it is greater than 0. For range of the k will be 0 to infinity. 0 to infinity. Okay, 0 to infinity. This is the way we find the k value. What time the difference is? Whenever there is no pulse function and zero order device, the k value is between 0 to infinity. See this one. 0 to infinity. Where the pulse function and the zero order device is present, the k value is between 0 to 5.8 to 25. That is nothing but it is very, okay, within the soft period of time intervals, it is going to be varying value. Whenever it is going to be for stable condition, it is going to be for large values. If you take as k equal to infinity, k equal to infinity. Okay, this is the way we have to find the stable of the system in application point of view. By using the first one is jury stability. After that one is Routh array. In jury stability, we got the k value is how much value? That is 5.0 to 5.8 to 29. In RH criteria, we got the k value is, that is same here. 0. K is between 5.2859. 8 to sorry 5.8 to 8 to 29. 8 to 29. We got this one value. So that is in case of the jury stability, in case of the Routh stability, for a given problem, the k range value is same. The k range value is same. Because of that one, if you go for the another one is RH, another one is without zero order voltage device, and pulse function without zero order device and pulse function equal some seconds. Pulse function, we got the range value to be equal to between 1 and 2. Okay, between 1 and 2. That is nothing but infinity. Sorry, between infinity. Okay, this is the way you have to find today class. Okay, now, so this is the problem of application point of view of the one problem I am taking, and I have to solve this problem into by using jury stability test and bilinear transformation method. We find the k range value. In that two conditions, k range value is same. After that one, I am going to taking the absent of pulse function and zero order device. So only the function is k by s into s plus 2 unity feedback. So I want to find that one into, you can say that one is in case of the zero order device, in case of the pulse function, we got the k range value. Whereas these two are in absent, that is only function is there. The pulse function is given to that one is 0 and zero order device is they given to 0. So we getting only G of S, system matrix, one of the system matrix. So if for that one, we get the stability as greater than 0, okay, greater than 0 and between infinity, up to infinity, okay. Thank you. You can use this one into Bogota test book. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.